Welcome to your first recording for geometry for the week of January 12th, 2016. So just a reminder that when you watch these recordings, you should be taking notes. So at this time, make sure you've got your math notebook out and you're ready to take notes as you watch the recording. And this is going to be really helpful for you as you go to do this week's assignments. Having the notes from this recording will be very helpful for you. And also note that you can click on pause if needed. You can click pause, and you can also rewind to hear something if you do need to. So at this time, I do want you to try these two warm-up questions in your math notebook. The first one, you are going to simplify the square root of 50. And in the second one, you are going to find the geometric mean of 6 and 9. So go ahead and click pause now and try these two problems in your math notebook. This will be a great review from last week. You will see these concepts again this week, so make sure that you get some good practice with this. And when you're ready to check your work with mine, go ahead and click play. All right, so to simplify a square root, what we need to do is first factor the number 50 and see if there are any square root factors in 50. So we want to find a factor that's a perfect square root. That's what we want to do when we're simplifying radicals. So we want to find a factor of 50 that's a perfect square. So I'm thinking 25 times 2. I know 2 times 25 gives me 50, and I also know that 25 is a perfect square root. So what I'm going to do is I'm going to rewrite the square root of 50. I'm going to rewrite it as 2 times 25. Because 2 times 25 is 50, which is the same square root we were trying to simplify. Now I'm going to focus on 25 because I know that 25 is a perfect square. When I take the square root of 25, what do you get? The square root of 25 is 5, so that's going to come on the outside of the square root sign because we took the square root of it. And the 2 that was in the square root sign is going to stay there because the square root of 2 is not a perfect square. So we're just going to leave it within the square root sign. And that's it. That's our answer. It reduces 50, the square root of 50 reduces to 5 square root 2. So the second question, find the geometric mean of 6 and 9. Well, I always like to write it as a proportion. That can be our first step here where we write 6 over x equals x over 8. And some of you might skip this step, and that's okay because we know when we have a proportion and we go to solve it, we're going to cross multiply. So when we cross multiply, we would have x squared equals, whoops, that should have been a 9, not an 8. In the bottom there, whoops, that's and then we take 6 times 9. Alrighty, so let's go ahead now and take 6 times 9, which is 54. And then we need to get x all alone. We need to solve for x. So x is being squared, so we need to do the opposite of what's being done. We need to do the opposite of what's being done. So the opposite of squaring something is taking the square root. So to get x all alone, I'm going to take the square root of both sides and go back to that blue color. So now we've got x equals the square root of 54. And we can actually simplify the square root of 54 doing what we did above. Find factors of 54 that are one that is a perfect square, and what we started with actually gives us that 9 times 6 because we know 9 is a perfect square. So when we take the square root of 9, we get 3, so that will come on the outside of our square root sign, and the 6 has to stay inside the square root sign because it is not a perfect square and we can't break it down into a perfect square. And that's our final answer, geometric mean of 9 and 6. All right, so let's move on. So today and this week, what are we doing? We're going to go over Unit 5, Session 3. This will be new for us, looking at special right triangles when we have triangles that have 45, 45, 90 degrees. Remember, every triangle has to add up to have a total of 180 degrees. The other type of special right triangle is when we have an angle with 30, 60, and 90 degrees. And again, that's going to add up to a total of 180 degrees because it's a triangle. Then we're going to take a quiz over every session we've done so far, sessions 1 through 3. And we're also going to, in this recording tape, review some problems from sessions 1 and 2 from last week. So let's go ahead and do that. And before we get going, just some tips for success. Since we're starting a brand new semester, make sure you're turning your work in on time. I can tell you the further you get behind, the harder it is to get caught up. So make sure you're turning your work in on time and starting the semester strong. Make sure you check your grades often. So not only do you check your overall grade, but you should also be checking on how you did on each assignment by clicking on the assignment in the grades tab to actually open that assignment up. Read my feedback and see what you missed. And remember, that'll help you to redo assignments, because remember, you can redo assignments. You cannot redo tests or quizzes, but you can redo assignments. And remember, if you do redo any assignment, you just need to send me a message. Otherwise, it won't get graded. Make sure you're reading the updates daily, and you're reading your emails and messages in Schoology daily. And then also make sure you're reading the weekly assignments document. And I really suggest that you print that out. You should not be relying on the list of assignments or doing the calendar. Don't just rely on that, because I'm going to give you special instructions on that weekly assignments document. So make sure you're reading that. It's in the updates page, and it's also got its own folder. All right, so Unit 5, Session 1. I'm pulling a problem straight from your homework assignment, number 4. So this is from Unit 5, Session 1, and this is problem number 4. So Unit 5, Session 1 really focused on the Pythagorean theorem is what Unit 5, Session 1 focused on. And the Pythagorean theorem we can only use with right triangles. So remember, you can only use the Pythagorean theorem with right triangles. And the formula that we use is a squared plus b squared equals c squared. And remember, the c squared is always going to be your longest side, the hypotenuse is always going to be the c squared, or whatever is alone on the one side of the equation. So this problem here says the safety rules for a playground states the height of a slide and the distance, so the height of the slide and the distance from the base of the ladder to the front of the slide. So we're talking about the height, which is over here, and then the distance from the base of the ladder to the front of the slide is this distance here. These two distances, when we compare them to one another, must be in the ratio of 3 to 5. And that's why we've got 3x and 5x labeled here. We've already got it labeled to represent this ratio. If a slide is about 8 feet long, so that is also already labeled, what are the height of the slide from the distance of the base of the ladder to the front of the slide? So what is the height of the slide and this distance? All right, well, everything's already labeled for us. So really, we just need to plug all these values into the Pythagorean theorem. So let's go ahead and do that. The Pythagorean theorem, we know, is a squared plus b squared equals c squared. So the hypotenuse is always going to be the c squared. So I'm going to go ahead and plug that in. The hypotenuse is 8 squared. We have 5x squared. We're going to square the entire thing plus 3x, and we're going to square that entire term. So 5x squared, you need to square both terms. We're going to square 5. 5 is 25. We're also going to square x, which becomes x squared. We'll do the same thing for 3x squared. The entire term is squared. 3 squared is 9. X squared is x squared. Equals 8 squared is 64. So now we need to add our like terms together. We've got 2x squared terms, so let's go ahead and those are like terms, so we can add those together. 25 plus 9 gives me, what, 34? 34x squared equals 64. Okay, getting closer here. So we want to get x squared all alone, so I'm going to divide each side by 34. We're working on getting x all alone. So divide each side by 34. So 64 divided by 34 is x squared equals, what is that? So I'm going to say x squared equals 64. I'm going to leave it as a fraction. I'm going to come back up here. I'm running out of space down there. So now I've got x squared equals 64 divided by 34. We need to get x all alone. So let's go ahead now and take the square root of both sides. To get x alone, x is being squared. To undo a square, we take the square root. That's the opposite of squaring something. Take the square root of both sides, and we get x equals the square root of 64 over 34. I'm going to go ahead and plug this into my calculator and see what I get. The square root of 64 divided by 34, I get 1.37. I'm going to stop at 2 decimal places. And we're not done. We need to find the height of the slide and then the distance from the ladder to the slide. So we just need to plug those values in for x in our diagram. So here we've got 5 times 1.37. 1.37 equals 5 times 1.37 equals 6.85 feet. So that's our one distance. And then the other distance is 3 times 1.37. And 3 times 1.37 gives us 4.11 feet. And that's that distance. So I just used the heights over here, 3x and 5x, and then plugged our x value in to find those two heights. So make sure that not only did you find x, not only did you solve for x, but you also found those two distances that you were asked for. I'm going to go on to the next slide, so if you need more time to finish up taking notes, go ahead and click pause. Alrighty, so in Unit 5, Session 2, we talked about similarity between right triangles. We talked about similarity in right triangles and how we can use proportions to solve for missing sides. So here we've got a right triangle. We've got 3 right triangles, right? We've got 2 small right triangles. We've got this small right triangle, this small right triangle, and then the big right triangle that takes up both of those right triangles. So we've got some lengths given to us. AD equals 12. I'm going to go ahead and label the lengths given. AD equals 12. CD equals 8. And we need to find BD. So what I'm going to do is I'm going to use this right triangle right here. And then I'm also going to compare it with this right triangle right here because we're given those lengths on those 2 right triangles. So what I like to do when I set up a proportion is look at 2 sides that are labeled, and I like to kind of compare or break up the right triangles. I always like to say that there's a small leg, a long leg, and a hypotenuse. And I'll set my proportions up using those patterns. Because remember, a proportion, you always have to compare the same 2 pieces. So let's see here. So in the yellow triangle, I'm given the short side is x, and the long side is 12. In my blue triangle, I'm given the short side is 8, and the long side is x. So in both of these triangles, I'm given the long side of the triangle and the labeled side of the short. So the triangle pieces that are labeled are the long side and the short side for both triangles. So that's what I'm going to do to set up my proportion. So I'm going to compare, how about the short leg? I'm going to start with the yellow triangle. I'm going to say the short leg is 8 and the long leg is, whoops, not 8. I don't know why I keep saying 8 today when I'm not meaning to. Alrighty, the short leg is x, the long leg of the yellow triangle is 12. So let's compare the short leg of the blue triangle to the long leg of the blue triangle. So the short leg of the blue triangle is 8, and the long leg of the blue triangle is x. And so we compared the short to the short to the long leg. Now we've got a proportion set up where we can solve for x. So we're going to cross multiply. X squared equals 8 times 12. 8 times 12 is 96. So x squared, again, we need to take the square root of both sides to solve for x. The square root of 96, we get a decimal. 96. Trying to see if there's a perfect square in 96. There is. 16 times 6. The square root of 96 can break down into 16 times 6. So we can simplify that into 4 radical 6. So that's the length of x, BD. So we just found that length of BD by setting up proportions. And that's what you did all throughout Unit 5, Session 2. So moving on to Unit 5, Session 3. So this comes from Unit 5, Session 3. What you're learning, this is the new stuff for this week. 45, 45, 90 triangles. So that means, this is a special type of triangle. What that's saying is that you've got a 45-degree angle, a 45-degree angle, and a 90-degree angle. And anytime you have triangles that are broken up into these special types of angles, you're going to have a pattern that always occurs. So what that's going to be is, remember when we, back in first semester, we learned if you have 2 of the same angles, that means that the sides opposite those 2 angles will be the same. Same thing occurs here for a 45, 45, 90-degree triangle. The pattern is that the sides opposite the 45-degree angles will always be the same. And then that hypotenuse is going to follow a special pattern. That pattern will be that the length of the hypotenuse is going to be radical 2 times the length of the leg. So if we know the length of one of our legs, we know that the hypotenuse will be that length times radical 2. So let's do an example here. I'm going to give us one side length. Say that this side is 5, and we'll call this A, and we'll call this B. So if I tell you that this one length, we're given one side length, we should be able to find both the other missing sides, A and B. This is a B, not a 6. So what would be the length of A? Well, that's also going to be 5, right? Because it's opposite of our 2 congruent 45-degree angles. What would be the length of the hypotenuse? Well, remember, it's going to be the side length times radical 2. So it would be 5 times radical 2. And we're done. We solved that problem. Well, it's not always going to be, we're not always going to be given the side length. Sometimes you might be given the hypotenuse. So let's try an example where you're given a hypotenuse and you have to figure out the side lengths. So what if we are given the side length is, or I'm sorry, the hypotenuse is 3, and we want to find the 2 side lengths? Well, we know that the hypotenuse is always equal to x times radical 2. We always know that that's what the hypotenuse equals. So let's solve for x. Let's solve for x. We just set up an equation. Let's solve for x. So we're going to divide each side. I'm going to move this up so that I can do the math over here for us. We want to solve for x. Let's divide each side by radical 2. Divide each side by radical 2. So now we've got x equals 3 divided by radical 2. Now, we never want to have a radical in our denominator, so we need to rationalize the denominator. So to get rid of that radical 2 in the denominator, I'm going to multiply both the numerator and the denominator by radical 2. And we'll see what happens when we do that. So look at our denominator now. We're going to have, so we're multiplying. We're going to have 3 times radical 2, and then our denominator will have radical 2 times radical 2, which is radical 4, right? And what is the square root of 4? It's 2. So that'll give us, the square root of 4 is 2. So that is the value of x. Oops, that's what we just found x equals. So that means that will be this side length here and that side length there. So what you need to do is just take whatever hypotenuse's length is given and set it equal to what we know it equals, that x radical 2. So that's what we did when we started here. We knew that the side length that was given was 3, so we just said, well, 3 has to be equal to x radical 2, and then solve for x. You'll get to practice that this week, as well as working with 30, 60, 90 triangle patterns. So 30, 60, 90 triangle patterns aren't as straightforward as the 45, 45, 90, because the 45, 45, 90, we had 2 of the same angle measurements, where here all 3 angles are going to be different. So please make sure when you are solving 30, 60, 90 triangles that you're really paying attention to the location of the angles. So here's the pattern that you're always going to get. If you have between 60 and 90 degrees, if the length is x, then the length of the hypotenuse is going to be 2 times x, and then the length between 30 degrees and that 90 degrees will be x times radical 3. So make sure you pay attention to the location of the angle measurements, and we're going to see an example here of how we can find side lengths. All right, so let's say that we're given the length of our hypotenuse, which is always between that 60 and 30 degrees, and then we need to find the length of x and y. There we go. So there's our 90-degree angle. Alrighty, so let's go back up here. So we're given the hypotenuse, right? The hypotenuse is always represented with 2x. So all we need to do is say, okay, well, 16 equals 2x. That way we can find the length of, we can solve for x. So let's go ahead now and solve for x. We're going to do that by dividing each side by 2, and we get x equals 8. So that means if x equals 8, we now know that the length of x would have to be 8. So remember here, the length of x is between 60 and 90. So make sure between 60 and 90, that's going to be plain old x. So this length between 60 and 90 is going to be 8. So we got that solved. Now we need to figure out this length here, the length between 90 and 30. So between 90 and 30, the formula tells us to take the value of x and multiply it by radical 3. Well, we found that x equals 8, so we just need to take 8 times radical 3, and that's going to give us the distance from here to here, because it's represented by x times radical 3. So it would be 8 times the square root of 3, because the distance is represented by x times radical 3, which is actually 8 radical 3. So we found all of our distances between the length of our sides by using what we were first given and set it equal to what the pattern tells us. All right, so let's do another one. Let's see here. Let's change colors and go to the other triangle. Now I'm going to give us the length between the 30 and the 90 degrees as 11. And we want to find the length of the hypotenuse and the length of the leg between 60 and 90. All right, so what length were we given? We were given the length of the between the 30 and 90 degrees. So I go up here to I'm going to go up to this triangle up here. We're given the length between 30 and 90 degrees. So that's equal to x radical 3. So I know that this length from here to here, between the 30 and the 90 degrees, is equal to x radical 3. So we are given that that side length is equal to 11. So I'm going to set 11 equal to x radical 3 and solve for x. So to solve for x, I'm going to divide each side by radical 3, divide each side by radical 3. Again, now we've got x equals 11 over radical 3. We never want to have a radical in our denominator, so I'm going to rationalize that by multiplying each the numerator and the denominator by that same radical. That way, in our denominator, we'll have radical 3 times radical 3, which is radical 9. We know that the square root of 9 is 3, so that will become 3. And then we've got 11 radical 3 on the numerator. So there is our length for y, so for the hypotenuse. I'm going to get rid of y there, and I'm going to slide this. Well, we know now that the length is 11 radical 3 over 3. All right, so that is our value of x. That is our value of x. So we just found our value of x. I don't know why I just rewrote that up there. Sorry, I'm going to take that away. What we did was we just found our value of x. X equals, I'm going to write this up here. X equals, that's what I was trying to write it somewhere else. I didn't mean to write it next to there. That's our value of x. Now we know then that since the distance from between the 60, now we can start plugging in our values to the other missing pieces of the sides here. So the length between 60 and 90 is just plain old x. So the distance between the 60 and 90 degree angle is just plain old x. So that means that the length between 60 and 90 is going to be 11 radical 3 over 3. That's going to be that distance. Now, the only distance we're missing is the hypotenuse, which the hypotenuse is represented by 2x. So we're going to multiply 2 times 11 radical 3 over 3. When we do this, we'll just get, what, 22 radical 3 over 3. And that's our hypotenuse. So here's all of our side lengths. This one, and this one was given to us. And that's it. So that's going to be a wrap for today. I'm going to go to the next slide, so go ahead and click pause now if you need to. So you need to now complete the key phrase assignment for the week of 1/12, January 12th. So I've got the directions on how to do it in case you need reminded of how to complete the key phrase assignment. And then I want you to tell me 2 things that you learned today. 2 things that you learned today. And then go make sure you click submit and you're done. So remember to let me know if you have any questions as you are working this week.